Hi everyone, this is a question from past papers on second mate's exam, and it's on the list. A ship of 10,000 tons displacement has an initial GM of 0.5 meters. FSM, which is the free surface moment, is 120 ton meter, is listed 2 degrees to starboard. A shift in grain cargo of 100 ton took place by 6 meters horizontally to starboard and 2 meters vertically upwards. Find the resultant list. As you can see that in this question, the ship is already listed to 2 degrees to starboard, and then onwards, another shift of cargo took place. So initially, she was listed 2 degrees to starboard, then cargo also shifted to starboard, horizontally to starboard. So the list will increase. So in a question like this, which is where the ship is already listed, we must first find initial listing moment. And then we will find the listing moment caused due to shift of cargo. And since both are to starboard, they will add up and we will get the final listing moment. Then about the GM. So we will first see that there is a FSM given, free surface moment, and GM is 0.5 meter, which is GM solid, obviously. So we will find the FSC and find the GM fluid. The cargo also shifted 2 meters vertically upwards. So this will also affect the GM. So the ship's center of gravity will also move parallel to the cargo. That means vertically upwards. So G will move towards meta center, GM will reduce. So the final GM will reduce by a certain amount. We will find that out. So this is the main thing here. Now, in this question, because it's all about the shift of ship's center of gravity, so wherever we are talking about, we are referring to a horizontal shift of ship's center of gravity, GG1. I have drawn a bar on top of it, okay, which shows horizontal shift of G. And if there is a vertical arrow with the pointer, which is vertical shift of G. So this, because there will be a horizontal shift of G and there will be a vertical shift of G, so both have been differentiated by these arrows. One on top shows horizontal and one on the side vertical shows vertical. In the questions of list, we must understand this diagram. Okay, this is the vessel listed to starboard, and this is the center line as along the pointer I'm showing. So before the ship was upright, the center of gravity G, center of buoyancy B, both were on the center line, and the ship was upright. Now the ship is listed due to unequal weight distribution on port and starboard side of the vessel. So the ship's center of gravity, in this case, ship is listed to starboard, so ship's center of gravity has shifted to G1, which is horizontally to the starboard side, G2, G1. And center of buoyancy obviously will shift also from B to B1, directly below G1. So new center of gravity, new center of buoyancy, once again, they will be vertically in line with each other and ship will be in static equilibrium. Now, if you refer to this triangle, GG1M, where M is the initial meta center, this kind of formula calculation is assuming that the angle of list is small, say up to 9 or 10 degrees, less than 10 degrees, where we assume that meta center is fixed. So in this case, we can safely apply this formula GG1 upon GM is tan theta. Theta is angle of list. Is right angle, this triangle is right angle at G. So GG1 divided by GM. GG1 is the horizontal shift of center of gravity. And GM is the GM fluid, final GM fluid in the question. So now I can see that here the WL was the original water line when the ship was upright, so it's parallel to the deck of the ship. Now the new water line is W1L1. So let's proceed with the solution. Now, since the ship is already listed, we must have an initial listing moment. So I put here initial, and as I showed you in the diagram, GG1 divided by GM fluid is tan theta. And which GG1 is it? As you can see, I have drawn an arrow pointer on top of the GG1, horizontal, showing it's a horizontal shift of GG1. So GG1 divided by GM fluid is tan theta. Also, listing moment will be displacement W multiplied by horizontal shift of GG1. As you can see here in the same diagram here, you can see this. This is the capital W, which is displacement from the G1 downward, and GG1 is the horizontal shift of G. So displacement multiplied by this horizontal shift of G from center line GG1 is listing moment. So what is the initial listing moment? GG1 multiplied by displacement, and initial GG1 divided by GM fluid is tan theta. So from here I can see that GG1 will be equal to GM fluid multiplied by tan theta from here. So in place of GG1, I can write GM fluid and theta multiplied by the displacement. This is the initial listing moment. Now we put the values for GM fluid. For that, you must find FSC. FSC, free surface correction, is free surface moment divided by displacement. FSM given in the question is 120, displacement is 10,000, and we get FSC 0.012 meters. So GM fluid will be GM solid minus FSC. So 0.5 minus 0.012, and we get 0.488 meters. This is GM fluid. So we put here GM fluid 0.488, tan theta, initial list is 2 degrees, so tan of 2 degrees multiplied by displacement 10,000 tons. So I get 170.413 ton meter initial listing moment to starboard, because ship is listed 2 degrees to starboard. And now the shift of cargo takes place. So we come to the final condition. The shift of cargo has taken place horizontally as well as vertically upward. So vertically upward, what will be the shift in center of gravity of the vessel due to this shift of cargo? So GG1 vertically upward will be a moment, vertical moment divided by displacement. So what is vertical moment? Weight of cargo shifted 100 ton, and by how many meters it has shifted vertically upwards is 2 meters. D will be 2 meters here. So W into D 100 into 2 divided by 10,000. 0.02 meters. This is the vertical shift in center of gravity. Now, what will be my GM fluid? GM fluid was initially 0.488. It will further reduce by 0.02 meters because G has shifted upward, because cargo has shifted upward, G has shifted upward towards the meta center. So that reduces the GM. So I subtract this GG1 and I get 0.468 meters. This is the new GM fluid due to shift of cargo. FSC has not changed because FSC depends upon FSM and displacement. FSM has not changed because no change in liquids has taken place on the ship. Displacement has not taken place. Cargo has only shifted internally. So no change in the FSC. So we can just take the original GM fluid and just subtract this GG1 vertical shift of center of gravity, which is upward. So GM reduces and it becomes 0.468 meters. What's going to be the final listing moment? Final listing moment, because as I told you, both initial listing moment is also to starboard and cargo also has shifted to starboard. So both listing moments will be added. Initial listing moment plus listing moment due to shift of cargo, horizontal shift of cargo. So initial listing moment, as we found below before, is 170.413. The listing moment due to cargo will be added. Cargo was 100 ton and it shifted 6 meters horizontally. So 100 into 6 is the listing moment due to shift of cargo. Both will get added up and we get final listing moment 770.413 ton meter to starboard. And once again, the listing moment is given by displacement multiplied by horizontal shift of G. So in our case, what will be the final, in the final case, what will be the GG1, horizontal shift of G? Final listing moment divided by displacement. And final listing moment we found here 770.413 divided by displacement 10,000. Once again, for list, tan theta is GG1 upon GM fluid, horizontal GG1 upon GM fluid. Horizontal GG1 I have here 770.43413 upon 10,000. And once again, and I also divide by the GM fluid, 0.468 as found here. This gave me 0.164618 and I take tan inverse, theta becomes 9.35 degrees to starboard. This is the resultant list. The vessel will be listing 9.35 degrees to starboard because of this shift of cargo. Okay, thank you very much. And you can go through it again and leave your comments. Also share with others who are giving the exams so they're also benefited. Thank you.